This video is about comparing elements and compounds. Let's explore the properties of elements and compounds. For example, why is sodium chloride or table salt safe to eat, but the individual elements, sodium and chlorine, are not? Elements are made up of only one type of atom. The element hydrogen exists as molecules, each with two hydrogen atoms joined together. Compounds, like water, are molecules made up of different atoms, in this case, two hydrogen atoms and one oxygen atom. A compound is formed when atoms of different elements react and join. Water is produced from the chemical reaction between hydrogen and oxygen. Two hydrogen molecules react with one oxygen molecule to produce two water molecules. Compounds have different properties than the elements they are made from because the atoms are joined differently. For example, combining carbon and oxygen yields carbon dioxide, a gas used in fizzy drinks and fire extinguishers. It is important to remember that a compound is not a mixture. In a mixture, like hydrogen and oxygen gas that have not reacted, the molecules remain separate. In a compound like water, the atoms are chemically joined together. To name simple compounds of metals and nonmetals, first, write down the name of the metal. Second, write the nonmetal's name, changing the ending to "ide." For example, magnesium and oxygen make magnesium oxide. Many compounds contain more than two elements. For compounds with two elements plus oxygen, the ending of the other nonmetal usually changes to "ate." The NID table provides examples of these naming conventions. A compound contains atoms from different elements chemically joined together and always has a fixed composition. Element symbols are used as shorthand for compound names, combining them to give the formula of the compound. For example, the formula for carbon dioxide is CO2. A formula uses the symbols of the elements in a compound. When there is more than one atom of an element, the number is written after the symbol. The formula shows the ratio of atoms in a compound. What is the formula for each of these compounds? Remember to put the metal first. For titanium oxide, with one titanium atom and two oxygen atoms, the formula is titanium 4 oxide. For lithium oxide, with two lithium atoms and one oxygen atom, the formula is lithium oxide. For aluminium chloride, with one aluminium atom and three chlorine atoms, the formula is aluminium chloride. Let's find the formula for these compounds. Silicon chloride has one silicon atom and four chlorine atoms, giving the formula silicon chloride. Manganese oxide has one manganese atom and two oxygen atoms, making the formula manganese 4 oxide. Aluminium oxide has two aluminium atoms and three oxygen atoms, resulting in the formula aluminium oxide. A formula shows the ratio of atoms in a compound. For example, the formula aluminium oxide shows a ratio of 2 aluminium atoms to 3 oxygen atoms. A word equation describes a chemical reaction. The steps are: put the reactants' names on the left, link multiple reactants with a plus sign, write an arrow in the middle, then put the products' names on the right, linking multiple products with a plus sign. When lead reacts with oxygen to form lead oxide, the word equation is lead plus oxygen yields lead oxide. Lead oxide is different from its elements because the lead and oxygen atoms in the product are joined differently than the atoms in the reactants. Let's practice writing word equations. For number 1, the word equation is calcium carbonate yields calcium oxide plus carbon dioxide. For number 2, it is magnesium plus hydrochloric acid yields magnesium chloride plus hydrogen. And for number 3, it is methane plus oxygen yields carbon dioxide plus water. This is a blank slide. A mixture contains two or more substances that are physically mixed, but not chemically reacted. Seawater is an example of a mixture. Unlike a compound, the proportions in a mixture are not fixed, and its properties are often an average of its ingredients. Liquids that do not mix are described as immiscible. Examples include water with oil or water with petrol. On a small scale, immiscible liquids can be separated by removing the top layer using a pipette, as shown in the diagram. Liquids that do mix are described as miscible. Examples are water with alcohol or petrol with kerosene. Miscible liquids can be separated by boiling because the components have different boiling points. A condenser is used to recover the liquids as they vaporize and cool back to a liquid. Various techniques can be used to separate different mixtures, such as separating funnel for immiscible liquids, distillation for miscible liquids, and filtration for insoluble solids. To summarize, key terms include atom, boiling point, compound, element, formula, immiscible, miscible, and mixture. These concepts are fundamental to understanding the nature of matter.